So the last part of this FRQ may look kind of daunting. It says show that G double prime is that gigantic mess right there. And then it asks some stuff about local mins, and we'll worry about that in a moment. First thing I'm going to do is find that G double prime. So what I'm going to do is, I know G prime is this, so G double prime is just going to be the derivative of that. So I'm going to rewrite that down here. G prime of x is minus 2. I'm going to do, oops. Sorry, I had a typo there, but whatever. So just notice that I rewrote this right here, but I just wrote it with brackets because I don't want to get as confused by having so many different parentheses. So I got parentheses inside and the brackets here. So to do this derivative, notice I've got some function here being multiplied by another function here. So that means that I have to do product rule. And that's going to take me to G double prime, which is what they're asking me for. They're basically telling me the final answer. So I'm going to do the derivative of this thing. G double prime of x is equal to, so the green derivative, well, derivative of e to the is e to the, sorry, I'm going to do derivative of first times the second. So I'm going to do the green derivative first. So derivative of e to the is e to the, but then I need to do chain rule. So I get minus 2e to the negative 2x. That's the derivative first. Now I have to write the second, so I rewrite this thing. So that gives me, open bracket, 3f of x plus 2f prime of x, close bracket. And then the second part of product rule, give myself some more space here. The second part of product rule is to do derivative of the second times the first. So I'm going to do the red derivative times the green. I'm actually going to write the green just as is at first because I like to have that e to the out front, e to the negative 2x. And now I need to do the derivative of the red. Well, what's the derivative of 3f? It's 3f prime of x. And then what's the derivative of 2f prime? Well, that's plus 2f double prime of x. Close, close. Alright, so that still is not what we have here, but notice I've got some f, there's some f stuff there, f prime, f prime, f prime, f double prime, f double prime. So I feel like I'm getting closer to what I have here. Now what I need to do is just rewrite it so that everything is in the same bracket. So I'm going to do this in 2 steps. I guess. So the first term is going to be this, and then the next term is going to be that product. So I'm going to have G double prime is equal to minus this product gives me minus 6. Actually, you know how I'm going to do this? I'll go ahead and do it this way because I think it is the most natural way to do it. You could pull your e to the negative 2x's out and make this easier, but I have e to the, I get this product is minus 6 e to the negative 2x times f of x. And then this product is minus 4e to the negative 2x times f prime of x. And then this product is equal to plus 3e to the negative 2x times f prime of x. Notice these two are going to be able to be combined in a little bit. And then my last term is this product, so that gives me plus 2e to the negative 2x times f double prime of x. Now, it looks terrible, but remember, it's supposed to kind of look a little terrible, right? Anyway, this is equal to, so I'm going to pull my e to the negative 2x out. E to the negative 2x, because I have that in this term, this term, this term, this term. So I have it in every term. And notice in my goal answer, it's pulled out there. So I've got e to the negative 2x times, open bracket, open bracket, minus 6f of x, that's this term, minus 4f prime of x, that's this term, plus 3f prime of x, this term, plus 2f double prime of x, which simplifies to, all I have to do is combine these two, and then I have that answer that I'm looking for up top. So that is e to the negative 2x, open bracket, minus 6f of x. I just copied this. These two are going to come together to give me a minus f prime of x, and then plus 2f double prime of x. And that's that part completed. I guess I'll leave it there for a moment in case you need to soak that up. So the next part of this question asks, does G have a local min at x equal to 0? So I've kind of switched the screen up a little bit here. We showed that this was true already just a moment ago. This was some work from part C. And then I wrote the question that they're asking us here. Does G have a local min at x equals 0? So first off, when I see this one, I think second derivative test. The second derivative test, well, I'm looking for a local min, right? Does it say local min? No, it says local max. Fixed. So anyway, the second derivative test says that if f prime of some value is 0, well, that would make it flat here, right there. And it's concave down, that makes it have a maximum. So if f prime of a is 0 and f double prime of a is equal to a negative number, or more formally is less than 0, then we get a maximum. So the reason why I pulled up this is because I know that f prime, or in this case we're looking at g prime of 0 is 0. So I have that g prime of 0 is equal to 0. Now all I need to do is, if I can show that g double prime of 0 is a negative number, then I know that the second derivative test tells me that we have a maximum here. So I have g double prime here. So g double prime of 0 is equal to e to the negative 2x, or e to the negative 2x at x equals 0 gives me 1, times, I get minus 6 times f of 0 is 2, so minus 6 times 2. And then I get this piece, so that says minus f prime of x. I know that f prime is negative 3, so I get plus 3 with the double negative there. And then this guy right here says 2f prime of x, right? So f prime of 0 is 0, so plus 2 times 0. And notice I get the 1 just multiplies in to not change anything. I get minus 12 plus 3, which is minus 9. So that fits this right here, which is what I was looking for. So the answer to does it have a local min, I say yes. After having shown this work, I can say yes, local max, not min, at x equal to 0 by second derivative test. And then we're done.